Hey, this video is on the one sample t-test. We use a t-test because there's a sample and then there's the population mean that we're trying to calculate to see if our differences in our sample or even our population that we have is different from the standard population. Let's look at this example here. McFarland Insurance Company claims department reports the mean cost to process a claim is $60. So the insurance company's claims department reports that the average cost to process a claim is $60. An industry comparison showed this amount to be larger than other companies. So the company instituted a cost-cutting measure, and to evaluate the cost-cutting measure, a random sample was taken of 26 claims processed the last month, and the cost to process each claim was recorded. See below. Well, that's over here onto the side, obviously. At the 0.01 significance level, is it reasonable to conclude the mean cost to process a claim is now less than $60? So what are we looking at? Always look at your alternative hypothesis. Now we're testing the null hypothesis, which means you'll see the null always has the equal sign because the null is saying our sample. Now in this case it's using the population. In this specific example, the reason why they're using the population symbol is because this is the entirety of each day of that month. All right, so we have a population, but we could call it a sample population. It's really not that important at this point. This would be the same calculation if this was the X with the bar over it. So my null hypothesis is no difference. It's equal. Now, my alternative hypothesis is our sample or our population for this month less than the national average or whatever they say the industry average is. So when we're doing a one sample t-test, what we're talking about is testing to see if our sample or our population that we're looking at is different from what we would call the standard. So remember, in the past videos I've used the blood pressure. This would be like, okay, the standard blood pressure is 120/80, and is our group, our sample, maybe that's the college athletes, are their blood pressure lower than the norm, right? Or is it higher than the norm? That is, we're comparing our sample or our specific population to the norm. So many times we're saying that the normal is $60 in this case. So our alternative hypothesis is our sample data, or population data in this case, less than the norm at the 0.01 significance level? Now, the interesting thing about the one sample t-test is if I do my data analysis, so remember, first of all, if we're going to do this in data analysis, so come up here to your home. We're on home right now in Excel. We want to go across here to the data tab, click on data, and go all the way across and see if you have this data analysis installed. If you don't, then we need to install that. Let's come back to our data. I'm going to go to a different sheet so we can look at this, and we're going to see what we're given. Now we're going to calculate the t-test here. This is the 0.01 significance level. Our population mean is 60, and we have 26 in our sample. All right, so we don't need to worry about degrees of freedom. That's something that we need if we're going to look it up in a chart, like many statistics classes or books want you to look this up in the back of the book, so to speak, right? So we're on our data tab, and then we're going to go across and we see data analysis. And if we click on data analysis, and we have two sample equal variances, two sample assuming unequal variances, and paired two sample for means. We have a video on each one of these coming up. However, we don't see anyone that says a 1 sample t. So what we have to do is we need to trick Excel into knowing that we're doing a 1 sample t, but we're going to tell Excel we're using this 2 sample t assuming equal variances. That's what we're going to use in this example here. So let's go out. Now the way we do this is, what is our population mean? Oh, it's 60. So I'm going to put 60 there. I'm going to go down and I'm going to go 60 there. And I do that because now I can carry this, I can copy this down by just clicking that little dot and bringing 60. So basically think about this. This is what we're tricking it into thinking that this is a separate sample, which in reality, in this example, it's a different population. But this population mean is 60. And in this case, the variance in this is 0. Now we know that there's some variance, but this is how we're going to trick Excel into calculating a 1 sample t-test. So let's go back up, data analysis, and we're going to go down to 2 sample, assuming equal variances, and we're going to hit OK. And here's our little thing. Now, so variable 1, we're going to just put that in there. And then variable 2, we're going to choose this column, which is all 60. So we're going to get obviously the mean is going to be 60. Now, hypothesis mean difference, we always put 0 there because what are we doing? We're testing the null hypothesis. The mean we're testing is the null, that there is no difference. Alpha, now you could put labels if you had labels up here. We don't in this case. What is our alpha? We've got to check to make sure what's given to us because what they're asking for is 0.01. So we have to make sure we put 0.01 there. And then I always like to have it, if I like to have it right here so I can see. So I'm going to hit output range, and then I'm going to just put, oh, that looks really good right there, J5. Let's put it in J5. And so it's displayed right here. And we're going to hit OK. And there we go. And instantaneously, it gives us all of this data. Now here you can see our mean for our group or our sample is 56.42, and of course here obviously this is 60, right? Now here we have the t statistic. It's given us this calculation. Let me come up here so I can get this so we can see it. There's my t statistic that it's asking us for. Now we have to determine always on this data analysis ToolPak are we talking about a one-tailed or a two-tailed, right? A one-tailed or a two-tailed. Now, how do we know? Well, let's go back to our hypothesis. So does this have, and we're checking our alternative hypothesis says, is this one less than that one? Is this one less than that one, right? So remember, is this one sample different from that? Is this one sample different from that? So we're going with the one-tailed test. Now, here's the critical value. The critical value is 2.40, 2.4, and our t statistic is a negative. Now, this could be a negative minus 2.4, but the point is this does not fall within the rejection region, right? Because the rejection region would have to be greater than 2.4 or less than negative 2.4 for this to be significant. So what is our conclusion? Let's go back over here. Here's my 6 steps. This book uses 6 steps. Some uses more. But it says make the decision. The decision is to not reject the null, right? Formulate the decision. If the null hypothesis, reject if t is less than. So here we take the example. Do not reject the null. Trick Excel into calculating a 1 sample t-test.